Hi everybody, I want to talk about stair framing and finish. I have here a little picture of the stairs leading up to the second story of my house. Came out pretty nice, kind of banged that out on the weekend. Hope you enjoy that. So stairs are all around us. Most homes have some kind of stairway, even if it's just a couple steps getting to the front door. But we use them to get in and out of buildings. We use them to go downstairs. We go upstairs. Um, it's unfortunately something that homeowners try and do themselves, and it turns out ugly and dangerous most of the time. There are very strict rules governing the height of the risers and the depth of the treads. If there's something that really gets the attention of the inspector every time we're trying to get a final on a house, it's the stairs. So we're going to talk about a lot of those regulations governing stairs. It's something that needs to be carefully laid out, carefully cut. We don't want to like overcut the stuff. We want to do kind of a nice job because stairs are dangerous. They're inherently dangerous, and then so I guess from that aspect, we want to make sure that everything's very carefully cut. If we overcut something, we're weakening the structure. On the other hand, the materials are generally kind of expensive too. So if we do like a sloppy job laying it out and a sloppy job cutting it and they're wrong, then we've just wasted a piece of wood that we can't use for anything else. So what I want to do in this lecture is kind of talk about the terminology. I want to go over how we would lay out and cut a set of stairs and some of the different ways of attaching those stairs. All right. First term is going to be the total rise. And if we talk about the total rise, that is the vertical distance from finished floor to finished floor. And that is the critical thing, I think, that people often ignore when they're laying out a set of stairs. When we are laying out some stringers and we're going to cut something, it's with the finished floor dimensions in mind. Okay, so if we're starting at a slab here and we're going up to the finished floor and we're going to add some carpet or hardwood flooring or something like that up at the top, that is what we're measuring to. Okay, we're measuring to the finished floor. Okay. The total run is the horizontal distance of the stairs. Okay, so how much room horizontally, how far into a room those stairs are going to project, that's what we're talking about when we say the total run. When we talk about the unit rise, that is the height of one step. We talk about the unit run, that is the depth of one step. Okay, the depth of one step. And so we're going to determine that the unit run is generally pretty consistent as long as we have space to put these stairs. The unit rise is going to vary. The unit rise is going to be unique to each set of stairs because it's going to be an even increment divided up by this total rise. Okay. Something that I think is very silly is that Pearson's, maybe some of the other lumberyards, sell pre-cut stair stringers. What are the odds that your total rise is going to match whatever they've got in the lumberyard? Okay, what's usually going to happen is you're going to have an odd-sized step, which is kind of lame, and hopefully you will all be able to figure this out and be able to cut your own set of stairs. And hopefully by the end of this lecture, you will agree with me that selling pre-cut stair stringers is silliness. Okay, moving on. Let's talk about some of the different parts. So if I talk about the stair stringers, it's almost always going to be 2x12 material, and that's like the framing of the staircase. Okay, we're going to support the treads and the risers with the stringers. There's almost always three, at least three, sometimes four, sometimes more, depending on how wide your staircase is. Other names for the stringers are jacks, stair jacks, or the stair carriage. All three of those can be used interchangeably: stringers, jacks, carriage. If we talk about the treads, that is the horizontal walking surface. That's this dark blue part right here. That's what we're standing on when we climb a set of stairs. Risers is the vertical part of the stairs. Okay. The riser covers the face of the stair stringers. There are certain instances where you don't need risers, an actual piece of material that's the riser, but generally inside any sort of finished staircase is going to have a riser covering up the stair stringers. Okay. And I would say there is a difference in like the riser being a piece of wood that we cut and nail on, and the unit rise, which is this dimension, okay, that we would rip the riser to. Okay, hopefully that makes sense. If I talk about the balustrade, that is like an umbrella term for all of the finished rail components. Okay, so we've got newel posts, are the big posts that are sometimes turned, sometimes built up like panels, but usually at like corners, terminations, stuff like that, you're going to have a newel post. And the baluster is the pickets, I guess is what a lot of people call those, balusters. And the handrail is going to tie into the newel posts. The balusters are going to somehow be housed into the handrail. And then there's a shoe rail, depending on what kind of staircase you have. But there's oftentimes a shoe rail that's a rail that the balusters are housed into. Okay. The nosing is this light blue thing here. It's the front edge of a tread. It typically extends beyond the face of the riser a little bit. And it seems kind of counterintuitive, but they have determined that a nosing actually makes stairs safer. It's like a visual alert to people that they need to pick up their foot, that there's a step happening right here, okay? So nosings are generally required, and there are dimensions that govern the size of the nosing. One thing I should mention, most of the dimensions as far as like handrail height, headrail height are always going to be measured from the nosing. Okay, so that's kind of the like the control on the set of stairs. Okay, you're not measuring like from the middle of the tread or something like that. You're always measuring from the nosing. All right, let's talk about some codes. This, might be a little dry, but these are things that we need to remember when we're building a set of stairs. These are for California. Okay, different states have different codes governing riser heights and tread depths and stuff like that. And then there's also a difference in commercial and residential. So I'll try and address commercial stair codes versus residential stair codes. So on a residential set of stairs, treads have to be a minimum of 10 inches deep. Okay, I have width because that's what I would rip the board to in theory. Okay. Generally speaking, when you have your nosing, like the finished tread, I guess what I'm trying to say, the finished tread is generally going to end up being wider than 10 inches because you're going to cap the riser and you're going to have a nosing on it. But when you lay out your set of stairs, you're usually laying it out and cutting the stringers at a 10-inch tread width, and then it gets built up from there. Okay. On commercial work, that tread depth is minimum 12 inches. Risers can't be any less than 4 inches or any taller than 7 3/4. In some parts of the country, you can go, I think you can go up to 8 inches, but in California, 7 3/4 is the absolute maximum riser height. And that's residential. If we're talking commercial, then 7 inches is the maximum. Okay, and again, that is the unit rise. The unit rise can't exceed 7 3/4, and the tread depth has to be at least 10 inches. You can't have any more than 3/8 variation in riser height. Okay, so let's say on my first step, I've got 7 inches. I could have a step that's 7 3/8 up at the top. It can't be from one step to the other, but I could have 7 inches down at the bottom and 7 3/8 up at the top, and that would be okay. If I had 7 and 7.5, that would not be compliant. A lot of the codes governing stairs have to do with maintaining consistent dimensions. And the reason is we develop a muscle memory when we're going up and down stairs. We get used to anticipating how far that drop is. And so if all of a sudden there's a riser height that's drastically different, it can cause falls and it can cause people to get hurt or die. Handrail height, hopefully you'll remember back to the ADA compliance lecture when 34 to 38 kept coming up. Like a bad penny, it kept coming up. It's the same with handrail height on a set of stairs. And it's always measured from the nosing, from the edge of the nosing. The top of the handrail has to be between 34 and 38 inches. Treads have to be at least 36 inches wide. If you're building a set of stairs inside that balustrade can encroach on the tread width. Okay, I can't exactly remember how much it can encroach, but the treads need to be 36 inches. It's okay to have a newel post and balusters inside that 36 inches. At the top and the bottom of the stairs, you need to have a 3x3 landing, minimum 3x3 landing. Okay, you can't, descend a set of stairs to a door. Okay, you have to have a landing at the bottom of those stairs and at the top. And then the maximum run you can have is 12 feet on a set of stairs. Or, excuse me, not a run, the rise. Okay, your staircase can have a total rise of 12 feet before you have to have a landing. Okay, there's a 3x3 landing, and then you can continue the rise. One thing that kind of trips people up, literally, is if you're terminating your stairs at a sloped surface, you want your targeted riser height to be in the center. Let's see if I can find my cursor. In the center of that tread. Okay, so let's say you're coming down to a severely sloped surface. You might have a 4-inch rise over here. You might have a 12-inch rise over here. Just due to the nature of that sloped surface, you're having to cut a tapered riser here. And that's okay as long as the center of this tread matches the unit rise of all the other steps. If you're building some steps outside, pouring some concrete steps or building some wood steps or whatever, you want to build in some drainage onto those steps so that water doesn't puddle on the stairs. Water can freeze and turn into ice and become a hazard. So you want to build in some drainage, but you can't exceed 1/4 inch per foot for that drainage. On your set of stairs, you need to have a minimum of 6'8" headroom, and that's from the line of the tread nosing. Okay, if you measure from the nosing up, you need to have 6'8" clear of headroom. Okay, and so this is mostly dealing, pretend we're not just looking at an exterior set of stairs here. Pretend we're inside a house and you're ascending a set of stairs, and the second floor is potentially going to get encroached on by those set of stairs. Okay, you have to have at least 6'8" from the nosing of the stair to the bottom of that second floor, whatever the drywall lid is or whatever the lowest point of that second floor is. You have to have at least 6'8" of headroom. So that can determine either how your stairs are built, what your tread depth is. Okay, maybe you have to shorten your tread depth up so that you get down the stairs faster before you run into that second floor. Or maybe you have to move that second floor back, cut that opening, that stairwell opening larger so that you can maintain that 6'8" headroom. If you have more than 3 treads, or if you have 4 risers, you have to install a handrail. And so generally when we're building a deck at the CR house, I really try and limit the number of steps that we have, because building handrails is generally a lot of work and it takes a lot of time, and mistakes are kind of costly. Okay, so I generally try and avoid a situation where we have more than 4 risers. Okay, but if you have to put in a handrail, there are codes that dictate the dimensions and the spacing of that handrail. So we already know that it has to be 34 to 38 inches from the nosing to the top of the handrail. It also has to be at least 1.25 inches in diameter and no more than 2 inches in diameter. You'll see a lot of full round at the lumber yards. Sometimes it's used for closet rods, sometimes it's used for handrails. Okay, it's really common. It's grippable. You have to have some sort of grippable handrail. You don't have to use that full round. You can make something. There's a special mushroom cap that you can attach to stuff that is compliant, but you can't just nail a 2x4 to the wall and have that be your handrail. And the other thing is, it has to project off the face of the wall at least 1.5 inches so that you can get your hand around it. Okay. One thing that I don't have on here, sometimes you'll see some kind of homeowner built handrails that don't return back to the wall. Okay, and that's another thing, is they have to return back to the wall. Okay, so that you can't hook your sleeve on the handrail or get caught, something like that. Okay.